This is the third in a series of 3 videos on calculating the area under a curve. In this video I will explain how to calculate the area between a curve and a line. Now the next thing we're going to do is find the area enclosed between a curve and a So for example, we're going to find the area enclosed between the curve y equals x into 4 minus x and the line y equals x. So the first thing we've got to do is sketch the curve and the line. X into 4 minus x is a quadratic with negative x squared coefficient, and so it will have a maximum. It will pass through x is 0 and x equals 4, so it looks like that. And y equals x, of course, is a straight line through the origin with gradient 1. So the required area then is the area here between the curve and the line, which is shaded. Now, how do we calculate this? So to calculate this area, we calculate the area under the curve, but we need to do that between x equals 0 and this point here. And that is the point, the x-coordinate of that point is the point of intersection of the line and the curve. Note that is not the area under the curve between 0 and 3, because that would include a little bit here. And we don't want that because we need the area under the curve between 0 and this point there, which would be this. And then we need to subtract the area of the triangle. So, which we'll call that A2, we'll call the whole area A1. And so A, the area required, is A1, the area under the curve above the x-axis, minus A2, the area of the triangle. So first we need to find the point of intersection P, and we do that by solving x 4 minus x, or y equals x 4 minus x, and y equals x simultaneously. We can just substitute x equals x 4 minus x, and expanding that, x equals 4x minus x squared. If we put the right hand side over to the left hand side, we'll put x squared and subtracting 4x minus 3x equals 0. So we have x minus 3 equals 0. So the point of intersection x equals 3, and this point here is 3. Of course, this is 4. I believe I said 3 before, but this is 4 where the curve crosses the x-axis. So the area A is the area under the curve between x equals 0 and x equals 3, and that's A1, minus the area of the triangle OPQ, where Q is this point on the x-axis, and that is A2. So A1 then is the integral from 0 to 3 of x 4 minus x dx, and the brackets equals the integral from 0 to 3 4x minus x squared dx, and integrating gives us 2x squared minus x cubed over 3 between 0 and 3, and that equals 2 times 9, 18, minus 27 over 3, which is 9, and evaluating at 0, we have 0, so the area is 9. And then the area of the triangle half base times height. The base is 3, and of course as the line is y equals x, the y coordinate of P is also 3, so the height is 3, which equals 9/2. So the area A is equal to the area under the curve 9 minus the area of the triangle 9/2, which is 9/2 square units. Now pause the video and try these two problems. The first problem, find the area enclosed by the curve y equals x, 3 minus x, and y equals x. First of all, we sketch curve crosses the x-axis at the origin and x equals 3 and has a maximum value, and so it looks like that, the shape of a quadratic, and the line y equals x, a straight line through the origin, gradient 1, and so we need to find the point P here, so that we can find the x coordinate, so that we can calculate the area under the curve and subtract the area of the triangle. So we solve y equals x into 3 minus x and y equals x simultaneously, and therefore we just can equate x, 3 minus x equal to x, 3x minus x squared equals x, and then adding the left hand side to the right hand side, we'll have x squared minus 3x plus x minus 2x equals 0, x minus 2 equals 0, and so the x coordinate of P is 2, and as y equals x, the y coordinate of P is also 2. So we need to integrate to find the area under the curve between 0 and 2. We'll call that A1, and the yellow area of the triangle A2. So A1 is equal to the integral between 0 and 2 of x, 3 minus x dx, expanding, that's the integral between 0 and 2 of 3x minus x squared dx, and integrating, we'll have 3x squared over 2 minus x cubed over 3 between 0 and 2. Substituting the limit 2, 3 times 4 over 2 is 6, minus 2 cubed, 8 over 3, and substituting 0 gives us 0. 6 minus 8 over 3 is 24 minus 8 all over 3, which is 18 minus 8 over 3, 10 over 3. So the area under the curve is 10 over 3. The area then of the triangle, half base times height, is half times 2 times 2. The height is also 2. So A2 equals half times 2 times 2, which is 2. So the area required is 10 over 3 minus 2, which is 4 over 3 square units. So for question 2, we need to find the area R, and the area R is to draw two lines down there perpendicular to the x-axis. This is the x-coordinate P, which is 1, and this is the x-coordinate of Q, which is 4. Then the area R is the area of the trapezium formed by P, Q, and the x-axis, and the two dotted lines there, minus the area under the curve. So R is the area under the trapezium, I'll call T, minus the area under the curve, which I'll call S. The first thing we need to do is find the y coordinates of P and Q. the curve y equals 2x plus 8 over x squared minus 5. So if x equals 1, y equals 2 plus 8 over 1 minus 5, which is 5. And when x is 4, y equals 2 times 2, that's 4, plus 8 over 16, which is a half, minus 5, which comes to 7 over 2. So the area of the trapezium T is equal to half times the sum of the parallel sides, that is the y coordinate of P plus the y coordinate of Q, so that's 5 plus 7 over 2, times the distance between them, which is 4 minus 1, 3, and that equals half times 17 over 2 times 3, which is 51 over 4. S is the area under the curve, and that's the integral of y dx between 1 and 4. So 2x. So S is the integral between 1 and 4 of 2x plus 8 over x squared minus 5 dx. We need to write that as a series of powers of x, so we'll write the 8 over x squared as 8x minus 2 minus 5 dx, and then integrating, 2x becomes x squared, x to the minus 2 is integrates x to the minus 1 over minus 1, multiplied by the 8, so that'd be minus 8 over minus times x to the minus 1, which is over x, minus integrate 5, you get 5x between 1 and 4. So evaluating at 4, we've got 16 minus 2, 8 over 4, minus 5x, which is 20, and evaluating at 1, we'll have 1 minus 8 minus 5, that. So that 16 minus 2 minus 20 is minus 6, minus 1 minus 8 minus 12 is minus, so minus 5 is minus 12, so minus 12 is plus 12, so that's minus 6 plus 12, which is 6. So we have R, the region we require is T minus S, which is 51 over 4 minus 6, which is, that's 12 3/4, so that's 6 3/4 square units. This is the end of the third and last video on finding the area under a curve. Now return to Study Smart and attempt the exercises provided.